All right, so last week we dealt with polynomials and classifying them and adding subtracting. This week we're going to move into multiplying polynomials. So in 5.1 we're just going to focus on multiplying with monomials. Remember, monomial is a single term, and then we'll multiply that to a polynomial. So our essential question is, how can you multiply polynomials by a monomial? So modeling polynomial multiplication. Okay, so I'm kind of going back to our multiplying with tiles. So we have 2. So I'm going to bring my 2 units over. And that's going to be multiplied by an x. And then a plus 1, so another unit tile. And we're going to multiply. So similar to like your multiplication charts, we're going to line these up. So I have a 1 tile versus times an x tile, and that's 1 times x, so that gives me that x, and then a 1 times a 1 out here is 1. Then on the bottom we have a 1 times x as well, and then a 1 times 1 there. So then what we end up having is we have 2 x's and then 2 unit tiles, which is, if we come back over here and we distribute, we get 2x plus 2. Okay, now let's look at that similar idea, but now we're going to do it with the 2x and then x minus 3. So do another one here. I have my x, and we have 2 of them this time. And then we have an x, and then we have a minus 3, so I have 3 of these tiles. And they're negative because it's a minus 3. All right, so now we have an x times x. So that gives us an x squared here. And then we have an x times a negative 1. And that gives us a negative x. And a negative x. And then a negative x there. And then we have an x squared here. And then negative x, negative x, and another negative x. So as we count these, we now have 2 x squareds and 6 negative x's. So as we go back over here and we distribute our 2x, we get 2x times x, which is a 2x squared. And then 2x times 3 is a negative 6x. Remember, on multiplying, bases are the same. We go ahead and add exponents. So x to the 1 and x to the 1, 1 plus 1 is 2. Now again, you won't have to do tiles if you don't want to, just showing you a visual representation of that. Okay, so let's continue on here. So multiplying monomials, so single monomials multiplied together. So again, we just multiply similar stuff, so numbers with numbers. So 6 times negative 4 is a negative 24. And then x cubed times x to the 4th. As we saw when we did exponent rules, we just add those 2 exponents, that becomes x to the 7th. And then here we get 5 times 7, which is 35. X times x is x squared, and then y squared times y. 2 plus 1 is 3, so we get y cubed. So a little reflection. In the product of powers property, do the bases need to be the same, or can they be different? So a little reflection, write your answer to that. We'll discuss that in class. All right, now multiplying a polynomial by a monomial. So we distribute so that 3x gets multiplied to 3x squared. So 3 times 3 is 9. X times x squared is x cubed. 3x times 6x, so 3 times 6 is 18. And then x times x is x squared. And then 3x times negative 5 is a negative 15x. And as you can see, it is in standard form already, so we're good there. We go from 3, 2, and 1. All right, example 7. Another variable in there, but process still the same. So 2 times 5 is 10. X times x squared. 1 plus 2 is 3. And then y times y. 1 plus 1 is 2. Distribute to the next one. 2 times 3 is 6. X times x is x squared. Y and y squared is y cubed. And then 2 times 7 is 14. X times x is x squared. Y times y is y squared. All right, so multiplying a polynomial by monomial to solve a real-world problem. So we have Harry's building a fish tank that is a rectangular prism. He wants the height of the tank to be 6 inches longer than the length and width. If he needs the volume to be as close as possible to 3,500 inches, what should be the length of the tank round to the nearest inch? So if the height, so we kind of have our tank here. So this height is 6 more than that distance and that distance. So if we don't know what this distance is, we'll call it x. And since they're the same, because this is 6 more than both of them, this then has to be x plus 6. So then we have x squared, because x times x on the bottom is x squared. It's just a square on the bottom. And then that is multiplied by our height, which is x plus 6. Remember, length times width, if you're going to see it all the way out, is we get x times x times x plus 6. Those x times x becomes x squared. Distribute, and we get x cubed plus 6x squared. Okay, now our goal is to get to 3,500 inches. So I'm going to create a table at this point where I have my x value. And we can say this is equal to y, or my output. We're just going to pick values. So let's start with 5. Substituting that in, so you get 5 cubed plus 6 times 5 squared. Typing that into a calculator. So when we work that out, we get 275, which is way low since we wanted 3,500. So we can pick a number. Let's go with 20. And substituting that in where we had 5 before. So 20 in there, we get 10,400. So now we've jumped up too high. Let's come back down some. Let's go 10. So substitute 10 in here. So substituting 10 in, we get 1,600. Which is low, but we're getting closer. So let's try 13. Which we get 3211. And if we did 14, we get 39, 20. And so closest to that is 32, 11. And we want to round to the nearest inch, which is 13. So then we'd say we want the length of the tank to be 13 inches. All right. You have 9 and 10 to try on your own there. Then you have your quizzes to go with that. And then your essential question: what properties and rules are used to multiply a multi-term polynomial by a monomial?